Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Jupiter from the Webb Space Telescope. So, what do we see here? Well, here we see an annotated image of Jupiter as imaged by the James Webb Space Telescope. Now we see Jupiter off to the right-hand side there. And it will look a little bit different. Of course, we're looking in the infrared. We're not going to see the distinct colors that we're used to seeing when we look at it in the visible. However, the light and dark banding pattern that we see is still present. We can see the great red spot there off to the right-hand side of Jupiter, which here will look very bright and white here as a higher level cloud. So when we look at Jupiter, we're not seeing a single surface. This is an atmosphere, but each of these cloud layers is at different levels. A lot of the lighter colors are much higher up in the atmosphere, and the darker colors are further down. So we're seeing multiple layers that could be 100 miles different in their positioning. So very different positions for these, and not just a smooth, uniform surface as we might just instinctively try to think about. Now we can also see the aurora on Jupiter. Aurora on Jupiter caused much like aurora here on Earth. Charged particles from the sun striking the magnetic field and striking near the magnetic poles. And that we can see the glow at the top and bottom, the northern and southern poles of Jupiter, and can see the aurora there. Very faintly, we can see the thin ring of Jupiter. Jupiter does have a ring just like all of the other giant planets. All four of them have rings. Saturn's are by far the most prominent that we see, but Jupiter has a very thin ring, and in fact, probably the least prominent ring among the four giant planets. Now, the other thing that we can see here are some of the moons, and one of them, Amalthea, is present off to the left there, is one of the moons of Jupiter, a relatively small moon. And it was discovered back in 1892. Now, this actually has the distinction of being the very last moon ever detected by visual observation, meaning somebody looking through a telescope at Jupiter and seeing the object moving. And that applies to any other moon in the solar system. This is the last one that was discovered like this. Previously, or more recently, I should say, they're discovered through pictures. We see images and we find that their object is moving, and we can figure out its orbit and that it is a moon. Now, it's actually a relatively small moon, only about 150 to 200 kilometers across. So that is very small compared to the other larger moons that we're used to looking at. But we can actually see the light of that in our image here, glowing in the infrared as imaged by the Webb Space Telescope. So remember, we're looking at things in infrared here. We're looking at much longer wavelengths. And while we see very similar structures, we're actually learning more about Jupiter by studying it this way. Instead of looking at just visible light, we can look at it with the Webb telescope, which not only looks in the infrared and gives us additional information there, but it's also a much larger telescope, and therefore it has a larger collecting area, able to bring out far more detail than we can possibly see with Hubble. And this is the largest telescope that has ever been launched, about 6 meters in size, more than twice the size of Hubble's mirror. So that was our picture of the day, titled Jupiter from the Webb Space Telescope. We'll be back again tomorrow for the next picture, previewed to be interstellar garlic. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.